Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at a test for independence using contingency tables and chi-squared. So basically what we're going to do is, because we have the same scenarios earlier, the total grades from a certain class, we're divvied up into three different groups. I looked at the number of stat majors that got the grades in that stat class, science majors, and then the non-science majors. And when you summed up those totals, you get the totals that you got in the previous chi-squared example that added up to 200 if you watch that video for the goodness of fit video, one population. So if we divvy up into those three different groups there, how can we compare the major and the observed grade? Are those two things independent? So in this case, when we were looking at our null and research hypothesis, we would say that grades, the letter grades, actually specify, and the major are dependent. And then the other one would be the null hypothesis, basically stating that the two variables in this case, the letter grades and the major, are independent. Okay, so how do we go about doing that? Well, I have divvied up these hypothetical numbers, made sure they added up this time so I didn't make the same mistake. And the first step you should go about doing these is to calculate your expected value. Well, that's not what I wanted to happen. Let's try that again. Looks like I'm running low on power. I need to hurry up. Actually, you know what? I'm going to pause this. Alright, we're back with some power. Now I don't have to worry anymore of losing this video. So we were calculating the expected values, and it's going to be the marginal of the row times the marginal of the column divided by the total. Technically, this entire table should be in terms of proportions, and you should do 20 over 200, 27 over 200, and turn those all into proportions. You can do all the calculations without doing that, and I choose not to deal with fractions, so I don't have to. So here what we got going on is, let's say for instance I was trying to find the expected value for the first spot. What I would do is I would take this marginal value here times this marginal value divided by that marginal value, and that would give me this 14.35. So again, marginal divided by total. Okay. For instance, if I wanted the D one, I would come over here and I would go to D column, and I would do this one times, which column was I in? That was in the non-science one, right? So it would be this one, 69 times 24 over 200. Okay. If you do that for every one of those spots, that's what you get there. And you can see this can be labor intensive, so please take your time on these calculations and double check them. Alright. Now comes for the actual calculation of the chi-squared value. So in order to do that, what you need to do is use this formula right there in order to calculate for each individual spot what that is. So I'm going to do that with you. If you want to pause and just go ahead and do these as we're going along, feel free. I am going to pause myself so I can fill in this table. I suggest you do the same. Okay, that was a little painful, but double, triple checked. These should be the values that you get whenever you do your observed minus your expected there, and you square it divided by your expected. You should get this table, and then when you sum up all of those values, you should get this as your chi-squared. This is your test statistic. Okay. Now what we got to do is we got to find our degrees of freedom and our chi-squared rejection point based on our alpha and degrees of freedom. So if we have more than one population, as we do in this problem, our degrees of freedom formula changes with these contingency tables a little bit. It becomes the number of rows minus 1 times the number of columns minus 1. Okay, so that's going to be, in this case, 5 minus 1 for the number of columns and 3 minus 1 for the number of rows. So that's going to be 3 minus 1 for the number of rows, and then 5 minus 1 for the number of columns, which then gives you 2 times 4, which is degrees of freedom of 8. So if we go back to our chi-square table, not Facebook, not that either, not that either. One of these, I promise you, is a chi-square table. There we go. Degrees of freedom of 8, and our alpha was 0.1. Gives me a chi-squared of 13.36. Okay, so we were far into our rejection region, weren't we, with the value of 13. Oh, there are my kiddos. These are my puppies. That's brown sugar, aka sugar. That's Jasmine up here, and that's Honey, aka Attila the Hun and Suge Knight. Crazy dogs. Anyway, back to statistics. Sorry about that. That's what I was looking for there. Our cutoff value was no, I forgot my cutoff value. What do I need? I need my table. Where's my table? There we are. So at degrees of freedom, 13.36 is what it was. 13.36. So this value here, this rejection region, starts at a chi-squared value of 13.36. That was degrees of freedom of 8. Here, I'll do it in a different color so you know we're plugging it in. That's degrees of freedom of 8 and alpha of 0.1. No, I said 0.05, so let's look at 0.05. I'm sorry. This is what happens when you do calculations all day and videos all day. You make silly mistakes. So 15.51. So it made it a little bit larger, but still not large enough. And that was degrees of freedom of 8 and 0.05. So I guess. Alright, and when we did our test statistic, we got a chi-squared value of 34.63, which is way over here in rejection region land. 34.63. So what were our two hypotheses? One said that there was agreement between the majors, we're not doing goodness of fit, we're doing independence. So the letter grades and the major are independent, and then the major and the letter grades are dependent for the research hypothesis. And since we are in the rejection region, we do go with the research hypothesis, and the conclusion therefore is that the letter grades and the major are dependent, which kind of makes sense, right? If you're a stat major, you better do better than let's say a phys ed major or a literary major or something like that. Okay, so you can see these calculations are the most tedious part. The first thing was to calculate your marginal probabilities here, and notice that my marginals for these guys were equal to the single probabilities when we did the one population. We just divvied up the stat class into 3 different majors, 3 different groups, and made it into 3 populations. And then to get the expectation value, what we do is we do this formula right here, where it's the marginal times the marginal over the total, and then you come up with this table, and then you do this observed table minus the expected table, square that answer, and then divide by the expected to get the chi-squared value. That's this formula up here. And then you get this table here, add them all up, you get your chi-squared test statistic, and then you come over here to your degrees of freedom, and that's going to be rows minus 1 times columns minus 1, which in this case gives you 2 times 4, which is 8. Alpha was 0.05. We were well in the rejection region, so they are dependent in this case. Hope that's clarified things for you a little bit. Main thing is to not make silly mistakes when you're calculating, so double, triple check your work, and make sure you add your marginals. They add up to 200, stuff like that. Okay? I hope I've helped. Thank you and have a nice day.